Hello, I hope you're doing great. So today we are going to talk a little bit about how you can automatically generate your models based on your entity framework DB context, right? So the first thing that you need is to have your DLLs in a specific directory. In this case, what we are going to do is we are going to use the directory where all of our DLLs for the application are compiled. And that's the directory only for reading all of the DLLs because we have to load the DLLs in the application context or in the application domain, um, so it can understand all of the dependencies on types that each of those assemblies may have, right? So for example, we are going to use fair play tube, right? Um, FairPlayTube has a DLL name, FairPlayTube.data access, and that data access or that project actually references the common DLL. So we have to load both in memories, right? In memory. So how you do that? So basically what we did in here is we created a small method generate models, right? And this generate models method will receive two parameters. The first parameter is going to be the destination folder, which is going to be the folder where we are going to create the classes with the properties we are going to generate. And the assemblies directory is actually the source directory where we have all of the DLLs that we need to create the models from, right? So we created this type mapping class. This type mapping class only has the source type, right? The source type name, the destination model name, and the destination model type code string. This is the model that, or the name of the type that's going to be generated, right? Which is going to be your model. And this is going to be the actual code for that class. So we go here, right? Basically, we load all of the DLL files in that directory, right? We pass the directory and we pass the filter or the search string. In this case is look for everything that is DLL. We iterate through all of those, and what we are going to do is we use the assembly load context, which says it represents the runtime concept of a scope for assembly loading, right? We use the default, is the default content for the main application and the static dependencies, and we basically add or invoke the load from assembly path, and we pass the assembly that we are iterating at that moment, right? So after we finish iterating through all of those, we have all of those DLLs already in memory, right? No matter which directory they are located, right? Now I know that my data access assembly is named .data access, right? So in this case, this is hard coded in here, but that can change. We can pass a specific name or something like that, right? Now I know that is using entity framework, and basically I know that entity framework data context inherit from DB context. So what I am going to do is I am going to get the types where the base type name is equals to DB context. And I use the single because I am sure that in this specific scenario, there is only one DB context created in there. Now I get the DB sets. Basically, the DB sets are going to be the public properties, right, that are declared on that type. So we are ignoring the inherit properties, right? This will give us all of the DB sets properties created in the custom created database context or DB context class, right? Then we iterate through all of the DB sets, right? And the DB set, it's basically a property map, a property of a class, right? So it's like a DB set using generic, and the generic parameter or argument is going to be the class that DB set is going to be using, right? So basically what I can do is we get the property type for that property, and we get the generic type argument since we know that these DB sets in this case are only using what type. I use the single, and this will give me the entity type, which is kind of the usual entity name or type that you use when you are coding in the entity framework, right? Then I get the entity properties, right? The entity properties again are going to be all of the properties which are public from the instance and declared in that class or in that type. We are ignoring the inherited um, properties. Then we use the string builder to create the class. So we use a using system, semicolon, right? We create a new line. We do public class, right? We set the name and we do this model. We iterate through all of the properties in the entity properties, right? We see it's here. And for now, we are ignoring everything that is a collection to ignore the navigation properties, right? Now we go when I mean to ignore the collections, right? Or we can create that as an array or something like that. But in this case, we just don't want to add that complexity. Uh, so we get the property type. We check if it is nullable, right? We need to create like the type with the nullable, right? Or we can create nullable and add the generics. Inside the generics, we add the actual type name. In this, if it is not nullable, we simply use the type name, right? Then we get the property name. We check if this is a custom defined type. This is basically to check if that property type it's a type defined in the same assembly, basically to check if it is navigation property, right? In those cases, if it is a navigation property, I don't want to use the same name. What I want to do is append the model so it makes reference to the actual, so the final code will make a reference to the actual model instead of an entity, right? We add the get set, right? In this case, everything is public because I get public, right? If it is not a custom type, we just do not append model and that property is going to be named exactly the same. Then the other thing that we do is, okay, we finalize the class, right? We close it. Then we use the C# syntax tree, parse text. We set what we have in the builder. We invoke the get root and we normalize white space. That will basically um, format the automatic generated code. Then we create a new type mapping. We add all of this in that type mapping. We add that to a list. We wait for all of that to finish, right? Then after the for each finishes, we go and iterate through all of the map types, right? And that will uh, create the file names. So when we go in here, you see that we have the map types. And for example, we have this application role, which is the source type name. It's going to be named application role model, right? And the class or the generated class is going to be this code using system, semicolon, right? Public class application role model, right? We have the properties, and this case, since this is using the actual types instead of the aliases, right? So it's using int 16, string, um, because we are not actually reading the base code. We are reading the generated assembly, right? So it doesn't have the short names as far as I know, right? And once all of that finishes, we will see that all of the code is actually generated, right? And this will be the models, right? User feedback model, user feedback model, right? And you see that all of that is in there. So we have the application user model, right? The originator IP address, source application, row creation, right? The names are the same, so you can then use Automapper because you know all of the names are exactly the same. And by using this kind of automatic generation of models, you are basically reducing a lot the time you need to develop your um, your models. So for example, let's say that you are using you are creating a Blazor WebAssembly application, right? With .NET Core hosted API. If you do that, you know that you usually have your shared project, which is supposed to have the classes that you are going to share between your controllers or your server project and the client project, right? However, a lot of people do that manually and it is time consuming. Um, if you are using things like Entity Framework, you don't want to have your entities in your client side. And so the things that you usually do is you create models, right, with the same properties or at least a subset of the properties, right, and some slight modifications in there, right? So basically with this, you can just auto-generate that part and then start customizing. Actually, I forgot to do something. This should not be public class. This should be public partial class. So you can go and extend it further by creating additional files with another partial class, right? And you will add whatever you need to add in there and avoid manually changing the auto-generated classes in case you need to auto-generate it again, right? So I hope this has been useful. Thank you very much and have a great day.